Hi, I'm Mina, and today I will share our project Cocomix, a system that utilizes comments to improve non-visual webtoon accessibility. This research was done at KAIST with awesome collaborators YunJung, Dasom, Haesoo, Uran, and Juho. While webtoons originated in South Korea, there has been a surge in popularity worldwide. For instance, Naver Webtoon has more than 67 million monthly active users. Webtoon is a type of digital comics published and read online. Optimized for web and mobile consumption, Webtoons adopted a single-strip display where readers can navigate with scrolling or swiping gestures. Unlike traditional media channels for comics, Webtoon platforms facilitate active participation of readers by enabling them to add comments on each episode. However, despite the popularity, blind or low-vision people cannot enjoy Webtoons with the lack of an accessible format. Most Webtoon platforms do not provide adequate alternative text, so this is the experience for a blind reader accessing Webtoons. Image. People have created braille comics, audiobooks, and added magnifying features. While promising, these approaches do not scale up as the production takes a great amount of cost and time, or it fails to serve the totally blind. One scalable approach would be adding image descriptions. To better understand the needs in Webtoon descriptions, we conducted a formative study. Participants were provided with descriptions generated by following conventional guidelines. From the interview, we distilled following challenges. First, users are confused when presented with recurring details in image descriptions. In this example, visually similar panels are shown to give an effect of a continuous action. However, when we describe each panel separately, it results in redundancy. Second, users have difficulty in processing the given information when reading the long description. This is because unlike general images, an episode of Webtoon often contains dozens of images. Third, users lack the control over the amount of details in the description. While one of the pleasure of reading comics is the ability to control the reading speed, blind readers have to passively listen to the provided description. In addition to the challenges, users also mentioned that while they have attempted to guess the content using comments, there were no efficient ways to utilize comments. Webtoons have abundant comments, and these comments implicitly highlight key moments in the content and provide additional context to the story. We present Cocomix, an interactive Webtoon reader that leverages comments into the design of novel Webtoon interactions. Cocomix takes two inputs, human-generated Webtoon description and reader comments. First, Cocomix provides comments-based adaptive description. The system automatically detects key panels and highlight in the description. Readers can listen to more detailed descriptions in key panels, which are frequently mentioned in comments. For non-key panels, abridged descriptions are provided as default, and users can selectively access details. For example, a user first listens to a short description followed by a sound notification that indicates there is more information to uncover.
Lito's eyes are glowing bright yellow.
Then, the user can double-tap to selectively access the details.
Smoke is blooming in front of her.
To detect key panels, our system automatically calculates comments focus score for each panel. We first extract keywords like characters and objects from comments, then measure how many each panel contain these keywords. With the next feature, panel-anchored comments, readers can easily access descriptive comments relevant to the current panel. Let's first look at how users can interact with the linked comments. After a user listens to the panel description, Cocomix indicates with a voiceover that there are relevant comments anchored to the panel.
One comment.
Then, the user can swipe upward to access comments, or decide to skip.
Comments mode. Her glowing eyes sent chills down my spine.
Descriptive comments are extracted through 3 stages. Prior to filtering, comments are pre-processed to autocorrect noisy and informal languages. This is because comments often contain grammatical errors, spelling mistakes, or slangs. Then, our pipeline first checks for reference to pre-populated Webtoon keywords in each comment. This filters out comments that contain no clear reference. In this example, The comment was filtered out as it is unclear who the "this" refers to. Second, it checks for dialogue text and leaves out all comments not in a statement form. In this stage, comments in a question or response form are removed. Finally, the pipeline checks for the tense of the root word from part-of-speech tags. This removes comments expressing wish or guess of the upcoming plot. In this example, the comment was filtered out because it anticipates future event rather than describing what happened. Now let's see how extracted comment is linked to a relevant panel. Our system calculates semantic similarity between panel description and comments using the sentence embedding method. If the similarity score passes our empirically set threshold of 85% and contains the same reference target, NIMS in this example, we anchor the comment as relevant to the panel. From pipeline evaluation with 10 cited readers, we evaluate the following statements. Cocomix output comments outperformed randomly selected comments in being more relevant to the story and referring to specific part of the content. We also evaluated Cocomix through a user study with 12 blind or low vision users. In this within-subject study, participants experienced two conditions, baseline and Cocomix, where baseline interface stripped all comments-driven features from Cocomix. After the study, we conducted interviews to draw qualitative findings. Among subjective ratings on both conditions, Cocomix was rated significantly higher in providing full control over the amount of description. Participants noted that they needed to check hidden details for the first few panels to build trust, and also mentioned that they enjoyed having the options to choose the amount of details. Cocomix was also rated significantly higher than the baseline in providing comments that are helpful for understanding the content. Users noted that when there are many comments on a specific part, they can guess that the panel covers an important topic. Also, some users said that comments can play a role of assuring them that they have understood the scene correctly. While current system takes human-generated description as input, in the future, we wish to support a more streamlined and automated generation of description. Also, we will consider incorporating other interaction data than comments, like gaze data or scroll data to indicate highlights. Also, we will explore how comments can be utilized to improve accessibility of other types of visual media, like photos from social media or videos on YouTube. With that, I would like to end my talk, and I would like to thank my collaborators again. Thank you.